It has to solve an inequality here, but it is a quadratic inequality because it has an x squared in it. Now this is a step up from a linear inequality, which would be something like 2x plus 3 greater or equal to 0. We would solve that just like a normal equation with an equal sign in there. We'd minus 3 from both sides and divide by 2. And then but you have to make sure you keep the inequality sign in there. And then, you don't really have to have any other knowledge. With a quadratic inequality, there is an extra step. However, what I would say is we are still solving it like an equation. So you know what? I think I'm just going to step straight into it and solve it like an equation. For this, you would factorize the quadratic first of all. That's always the first step for solving a quadratic. Try and see if it factorizes. If not, you're going to have to go into completing the square or the quadratic formula, but that's not actually necessary here, so I don't think I'm going to talk about it. So to factorize this, I'm going to need an x and an x to give me my x squared, and then I'm going to need two numbers that multiply to give minus 6 and add to give minus 5. Well, the factors are going to be 2 and 3, or 1 and 6, but one of them has to be negative to give me that minus 6. And as soon as I put a negative in one of these, when it's not there, I'm going to get 5, but when I put 1 in, it's not going to work, so I can cross that one out. This, however, if I make it minus 6, then I'm going to get my minus 6 when I multiply, but I am going to get my minus 5 when I add them together. So it's x plus 1 and x minus 6, and I've factorized my quadratic, but how am I going to do it from here? Well, what you have to do is you have to have some knowledge on quadratics, and we're going to do a little sketch. So this quadratic, the roots, if this was an equal to, I would get my roots as minus 1 and 6, because I'm basically solving x plus 1 equals 0 or x minus 6 equals 0. I don't think I'm going to go into any more than that, actually. But my roots would be at minus 1 and at 6. Now, why am I doing this? Because if I was to sketch the graph, it's a happy quadratic because it's got an x squared in there, one of these, rather than a sad quadratic, which is when you have a minus x squared in there. It's going to look like that. Actually, this is going to go for at minus 6 because that's the intercept. I'm going into more detail than needed, but another question could be to sketch the graph. And what I'm interested in now, and this is why the sketch is so useful, is I can just look at the graph and I can see where it's less than or equal to 0. I found where it's equal to 0, but it's going to be less than or equal to 0. I'm going to use a different color, sorry, through this little bit here. Yeah, because these are my values of the function, and they're less than or equal to 0 throughout the whole thing. So if I want to know the range of x where this thing is less than or equal to 0, it's going to be here, these values here. And so it's going to be from minus 1 inclusive, so minus 1 less than or equal to x, less than or equal to 6. And in fact, that is the answer. So essentially, solve this like a quadratic equation to get the roots, but then use the roots to sketch the graph and look where it's less than or equal to 0. I could solve greater than 0 by looking here and here. This is something that comes up all the time in A-level, and I think it can be overlooked at GCSE because you spend a lot of time solving quadratic equations, even using the formula, quadratic formula, completing the square. But you might just kind of dip into sketching graphs, and you need to sketch graphs before you try and attempt something like this, which is a quadratic inequality, because the best way of solving it, in my opinion, is being able to sketch the graph and look at it. Trying to just learn it is not the way to go. Because what I see sometimes is people do x squared less than 9, and they want to take a square root. They think, oh, I can square root that, and I'm going to get plus or minus 3 here. Works when it's an equation, does not work when it's a quadratic inequality. In fact, you should write this as x squared minus 9 less than 0. Factorize it by completing the square. Okay, and whilst the roots might be plus or minus 3, if we then draw the graph, we see in fact that it would be this region here, and it would be between minus 3 and 3, which is very different to what this is saying. Kind of went off on one a little bit there, but basically my summary is treat it like a quadratic equation by factorizing it and getting the roots, sketch the graph, and look at the region you're interested in, and then it will fall out and you can be happy with your quadratic inequalities.